Here's a short video on programming the SG Labs 3.4 GHz transverter. These devices have 4 memory channels that you can program in your own local oscillator if your IF offset is different to what comes standard, and there's a serial output on the board, and it looks like it's 3.3 volt logic. If that's the case, then you need a level converter for a standard serial output. So I've attached my crow probe to the transmit data so we can see whether or not this is actually the case. And if we go up here to the oscilloscope, let's focus on that, and now we'll turn the transverter on. And we get a waveform, and we can see that the amplitude there on the screen is 3.3 volts, so we're definitely going to need a level converter before we can plug this into the PC for programming. Level converters are fairly readily available on eBay, so I've got one here, and I'll plug that into the SG Labs transverter and we'll see how that goes. I've now plugged the level converter into the serial output of the SG Labs transverter. The level converter is a standard MAX 232 chip that will convert the 3 volt logic to 5 volts or better, depending on how much power you give it. You can go all the way up if you have a very old serial port, but generally we don't need that these days. Now if we turn on the transverter, we should get an output on the screen. As we do, hit return, and we can see a increasing cursor. Type in the IF we want for receive, hit return, do the same again for the transmit frequency. So you can have split transmit receive IFs if you require them. We don't care about the other memory positions, so we'll just let each position time out, at which point it will actually choose the defaults that are currently programmed in. So we're nearly done. As we can see, the different frequencies pass through, and one more to go, and once that times out, it will display channel 1, which is the currently saved frequency that it will power up as. And that's basically all there is to it. Have fun.